Hi, welcome to this lesson on analytical geometry, circles part 3. Let's have a look at question 4. A circle passes through the points A, 7, negative 4, and B, negative 5, negative 2. If its center lies on the line y plus 5 equals 2x, determine the equation of the circle. Okay, so quite a bit to unpack here. So first of all, we have 2 points on the circle, A, 7, and negative 4, which is somewhere over here. And then we've got the point negative 5, negative 2, which would be somewhere over here. Okay. Now, all we know is that a circle passes through these 2 points. So roughly it could potentially look something like this. Okay. And we don't know the center, but we know that the center does lie on this line, y plus 5 equals 2x. So what I'm going to do is I'm going to subtract 5 on both sides so I can get it into the general form mx plus c, which is a straight line. So I'm going to draw in that straight line and see where it is. So first of all, it's got a gradient of 2 and a y-intercept of 0, negative 5. So 0, negative 5, that's going to be somewhere over here, 0, negative 5. And it's got a positive, right? And let's just see, where's the x-intercept? So if I set y equals to 0, then x must equal 5 over 2, which is 2.5, which is somewhere over here, since 7 is all the way over here. Okay, so if I draw that straight line in, then it says that the center must be somewhere on this line here. Okay, let me just try and draw a better rough diagram for that center point, so that it looks like it's roughly somewhere there on the center. So it could look something like this. So this is the line 2x minus 5 in red. Okay. And we know that it does cut the x-axis here at 5 over 2, 0. Okay, 2.5, 0. But we know that the center is somewhere on this line. Okay. And we want to determine the equation of the circle. So because it doesn't look like the center is going to be on the origin, we can therefore conclude that the equation of the circle must have a non-center origin. So I'm going to put the center as HK. Let's call it that for now. So it's somewhere on the straight line. I'm just going to call it CHK. All right, so we know that essentially from the point B to that center point must be the radius R, and the same thing happens if I go from C to A. That must still be the radius R. Okay, so what does the equation look like? It's going to be x minus h all squared plus y minus k all squared equals r squared. Okay, so how can we now try and solve this equation? Okay, so first things first, what I'm going to notice is that I'm going to try and look for the value of r first. Okay, and r I can find in 2 different ways, by constructing right-angled triangles. Okay, towards that center point, or just using what we call the distance formula. Okay, so the distance formula, so the distance from the point B to the center C, that's going to be the square root of, okay, so I'm going to call x1, y1, h, and k, and in this case, x2, y2. So we know it's going to be x1, h, minus x2, negative 5, all squared, plus, then it's going to be y1, k, minus y2, which is negative 2, and all squared. All right. But before I carry on, I'm going to see an issue because I'm going to have an h and a k. If I can get this just in one variable, then it would help the calculation. So what I can do is I can observe that since this equation here, y equals 2x minus 5, that straight line has the center point on it, then I can conclude that if I substitute the x value of h into here, then I can find the y value, which is k. So if I substitute the point hk into the straight line equation, so it's going to be k equals 2h minus 5. So now I've got an expression for k in terms of h. So I can substitute that point in now. So here it's going to be h plus 5. So h plus 5 all squared plus this is going to be k plus 2. But we know what k is. It's 2h minus 5. So it's going to be 2h minus 5 plus 2. And that simplifies to 2h minus 3 all squared. So now I've got the distance between the line B and C, which is the radius r, as this expression here, square root of h plus 5 all squared plus 2h minus 3 all squared. All right, so that's one representation. So what I can do is I can square both sides and basically say the radius squared is equal to this expression here. Okay, so right now it's still a lot of algebra here, but before expanding or doing anything out, let's analyze the distance between A and C now. Because again, these are going to be equal because they are both radius. So by the same distance formula, I'm going to have, again, I'll call this one x2 and y2. So it's going to be h minus 7 all squared plus k minus negative 4 all squared. And again, we know that k, so this thing here simplifies to k plus 4, but we know k is 2h minus 5 from here, plus 4. So this ends up being the square root of h minus 7 all squared plus 2h minus 1. That's what that simplifies to in there. And that must equal the radius r. So again, r squared is equal to now h minus 7 all squared plus 2h minus 1 all squared. So look at this now. We have two equations, r squared and r squared is equal to these two different values. So we can use simultaneous equations now and equate the right-hand sides. So I have h plus 5 all squared plus 2h minus 3 all squared. That's for this term here. That must equal to h minus 7 all squared plus 2h minus 1 all squared. So here we've got an equation which is going to end up being quadratic in h, and it's only in one variable. So we can very much solve this equation. So let's go ahead and make some space and solve this equation. Okay, so let's go ahead and solve this now. So what I'm going to do is I'm going to expand both the left-hand side and the right-hand side. So if I square that first term, it's going to be h squared plus 10h plus 25. Then for this next term, it's going to be 4h squared. Then double the product. So the product is negative 6h. So double that is negative 12h. And then square negative 3 is 9. Okay, on the right-hand side, so here we just got to be careful and expand out our algebra correctly here. So take your time and don't rush it. Okay, so here h minus 7 all squared is going to be h squared minus 14h plus 49. And then over here, it's going to be plus 4h squared minus 4h plus 1. Okay, so let's clean up the terms on the left and the right. I have 1h squared and 4h squared, so it gives me 5h squared. Then I've got 10h and negative 12h, that gives me negative 2h. Then I've got 25 and plus 9, that gives me 34, equals. Here I've got h squared and 4h squared, that gives me 5h squared. That's promising, because the terms here on the square are the same. So it'll probably cancel out very nicely. Then I've got a negative 14h and a negative 4h, that's negative 18h. And then a 49 and a 1 gives me a 50. Okay, so I can subtract 5h squared from both sides, and I'm left with negative 2h plus 34 equals negative 18h plus 50. Now I'm going to add 18h on both sides. So on the left, I'll have 16h plus 34, and that's equal to 50. And therefore, I can subtract 34 on both sides, and I get 16h equals 16. Now that's quite nice in terms of the working out, yeah, because if I divide both sides by 16, I get h equals 1. And remember, we have an expression for k in terms of h. So if I substitute 1 in there, I'm going to get 2 times 1 minus 5, that's negative 3. So the coordinates I get c is 1, negative 3. And again, look where we place c, that makes sense. It looks like it's a positive 1 there, and it's in the negative y-axis, and we get negative 3. So obviously it's supposed to be a bit more down, but this is a rough drawing that I did, so it wasn't going to match up perfectly, but it gave us the correct sense of where the points should be in the quadrants. Okay, so to determine the equation of the circle, it's going to be x plus 1, x minus 1, it's the opposite sign always, squared, plus y plus 3 all squared equals r squared. Now remember, r squared, we actually had an expression that we worked out earlier, but we've erased it. But that's fine. We can just work it out again. So I'm just going to draw a right angle triangle here. So it is from -5. Okay, let's just put the points in here. -5, -2. And over here, we've got the points 1 and -3. So from -5 to 1, that's 6 units across. And then from -2 to -3, sorry. So you can see why the rough diagram worked against me here. Okay, so the point was below here, sorry. Okay, so it's going to be -5, -2. So it's supposed to end up here, but that's fine. And then the coordinate was 1, -3. Okay, so again, we moved across 6 units and we've gone up 1 unit. So it's going to be 6 squared plus 1 squared. So it's 36 plus 1 is 37. So the radius r is root 37. But that's fine, we want r squared, so it's just 37. So that is the equation of a circle that passes through those 2 points and the center lies on that line. And we can double check. Let's always double check to make sure that we are correct. So if I put in the points 7 and -4, let's see what happens. So 7 minus 1 is 6, and then -4 plus 3 is -1, and -1 squared is just +1. So 6 squared, 36 plus 1 is 37. So that's definitely a point. And if I take -5 and -2, -5, -1 is -6 all squared, -2 plus 3 is 1 squared, and that's still going to give you 37. Okay, so those 2 points definitely lie on this circle with that equation. And does the center point, 1, -3, lie on that line? Well, if I put y is -3, I have -3 plus 5 is 2, and 2x is 2 times 1 is 2. So again, it does lie on that line there. All right, so quite a long one. Here we have to keep track of our algebraic working out and making sure that we can keep track of all the points and working out correctly. All right, I'll see you in the next one.